Hi, I'm B from Nectar Mechanics, and welcome to part 4 of 3D printing my custom and transforming Optimus Prime figure. So, in the last video we looked at 3D printers, both how the machines work and the iterative design process of printing off our block model test prints. In today's video, however, we are finally going to be detailing him and turning him into a proper Prime. For this part of the project, we're going to be swapping from FreeCAD to Blender. As we looked at in the second video in this series, Blender is a surface mesh modeling program, which means it's going to be a lot better at getting those flowing details that we're after. Now, unfortunately, you're going to have to do some prep work before we start. It's a complicated project, so this is going to make life a lot easier, trust me. First up, I'm going to want to import all of my block model parts that I designed in FreeCAD, and make sure they're lined up in their robot mode configuration. Now, Blender is a bit of a CAD Swiss Army knife. It can do a bit of everything, including animation. I'm going to take advantage of this and select all of my parts, and then I'm going to press I to insert a keyframe. That tells all the parts that on frame 0, here in our timeline, that the parts need to be in this position that we just set. Now, if I scroll my playhead in the timeline to frame 20, I can move all my parts into their truck mode configuration and insert another keyframe. Now look at this. When I slide my playhead back and forth, the model will transform itself, letting me quickly see how the details we're about to add will look in both modes. People often ask me how I get my figures so accurate to the source material, and the answer is reference images. A lot of reference images. So make sure you get them from many different angles, not just front on, not just from the back. The more angles, the better, so that way you have an actual understanding of the shape of the object that you're trying to model. So with all that boring prep work out of the way, it's time to actually get started on detailing the model. And there's two main ways that I go about this. The first is just altering the base mesh. You see, Blender gives me access to all of the vertices of my object. So if it's already pretty close to what I want it to look like in the finalized version, you know, like the chest grill here, then I can just go into edit mode, tweak it so it's got the correct amount of vents, and we're done. The other is working with booleans. In Blender, if we add a boolean modifier to the object we're working on, and then select another object, we can either cut or add to that initial object using this new secondary one. A great example of cutting details into a part is on Prime's forearms here. I want to add some basic surface details, just to break up that big flat surface. So I'm going to make what I call a detail stamp, and line it up with the forearm. This stamp is never going to get printed off like all the other parts. It's just a bunch of details all sort of floating around. Once I make sure it's slightly digging into the forearm, I can perform my boolean action, and bam! All of those details are now indents on the forearm. Booleans aren't just a subtractive method of modeling though, they're also additive. So when I want to add windscreen wipers to Prime's glass plates here, I can model them separately, and once I'm happy with the shape, I can line them up and merge them into that block model part. The only downside of doing so many Boolean actions is that it can create what's known as messy topology. Messy what? Okay, I'm about to nerd out for a second, but stick with me. All 3D objects in a surface mesh modeling program are made up of vertices, edges, and faces. We ideally want to model in what's called triads or quads. You see how this cube has a bunch of random verts on its edge? They're not actually needed at all. And if we want to add modifiers later on, it's going to do some really weird math and cause a load of issues. An example of good topology would be only having the vertices you need. So in our cube's instance, it just needs the 8. This means we've got 4 vertices for each face, meaning it's made in nice quads. Unfortunately, when you're doing Boolean actions, it can sometimes add these random extra vertices when it's trying to figure out how best to merge your two objects together. And if you're doing lots of complicated shapes all at once, you might end up having an awful lot of cleanup time. The final bonus third method is modeling an object entirely from scratch. Normally when we model something, we want to start with what's called a primitive, a basic shape that resembles our end goal. Transformers' head sculpts don't really benefit from this. Instead, I start with a single vertex and extrude and manipulate more verts out, creating an entire mesh from scratch. When I'm happy with the sculpt, I'll perform a Boolean action to add our ball joint socket from the block model, but other than that, the head sculpts are entirely made from the ground up. So from here, it's just a matter of going around our model and seeing where's looking blank and could benefit from some details. A good rule of thumb I find when working on G1 bots is less is more. If you take a look at modern toys from the 86 line, they'll often have plenty of surface detail, but it's usually fairly simple indents that are also relatively big compared to the details on War for Cybertron figures from the past. They'll also often leave large blank spots to help break stuff up, otherwise it's way too much to take in properly and can look rather messy. While I'm adding these details, you might have noticed I've been flipping back and forth between both modes. You see, if I'm cutting into pieces, then everything should still transform fine, as all I'm doing is taking away material. But on parts where I'm adding, I need to double check I still have room for it all to fit nicely in truck mode. This flipping back and forth also lets me check if my robot mode specific details are going to clash with my truck mode specific ones, and vice versa. For example, I really want to give Prime his truck ladder, but if I line it up accurately to an actual truck, it's gonna be split up awkwardly in robot mode. So I'm gonna have to compromise and move it further back, so it's contained to only his arms in bot mode. If there is anything at all that you take from this series, it's that. Modeling a transforming toy is a battle of compromises. You ever wonder why those non-transforming toys always look so much closer to the cartoon models? Well, it's because they don't have to worry about the vehicle proportions making sense. A torso is just a torso. It doesn't need to double as a truck cab. The only way to get a hang of this balancing act is to decide what your priorities are with your model and go from there. For me, I like having authentic transformations in my figures, no faux parts. Yes, this means they'll never look quite as accurate to the source material as the faux parts would allow, but I hope it feels a lot more rewarding to transform back and forth. So we're almost finished actually, but one last thing I want to show you is that when we're printing figures at this scale, articulating hands are going to be extremely fragile. So let me show you how you can easily model one set of hands, pose them how you want, and print them off in those different poses to display how you wish. First up, we're going to want reference images again, and lots of them. Hands are notoriously difficult to model. Now, since these are robot hands, we can easily break our hand up into individual objects for each section of each finger, palm, thumb, making sure they all clip inside each other slightly. Now for this next step, it's essential that you've modeled your hand in an open natural pose, as we're going to once again take advantage of Blender's animation tools. It's going to get nerdy for a second again, but we can press Shift A to add an armature and go into edit mode to create bones for all of our hand segments. These digital bones won't be seen in the final print, they're essentially just controls for us to pose our hand in any form we want. Once our bones are lined up, we can select our finger segment, Shift select our bones, and then hit Control Tab. From here, we can choose Object to Bone from the parenting menu. We can then repeat this process for the rest of the hand, and now when we go into pose mode and move our bones, it moves our fingers almost like a digital action figure. So that's your hand. Now we can just copy paste this model, pose it in any form that we want, and then perform a ton of Boolean actions to fuse it all into one singular object. And as long as they all share the same connection method, in Prime's case here a ball joint, then you can just swap them in and out nice and easy. Alrighty, so with that out of the way, we're basically done. The only thing left to do is print off the bot and begin the assembly process. But before I do, I just want to say a huge thank you to everybody who's watched this series. When I first started modeling my own transforming figures, there was not a lot of great videos out there. So my hope is that this series has been those videos for someone else. And if I've helped at least one person over that beginner initial hurdle phase, then I'm very happy. So, once again, thank you for sticking with me, and let's take a look at the final print. Now that is just prime. Sorry, I had to. If you want to download these files for yourself and print off your own copy, the link to my cults page will be available down the description below. I've even got a how to assemble video to make this process as easy as I can for you. Otherwise, if you like what you saw and you want to see more, feel free to subscribe, and I'll catch you next time. Farewell!